Let's talk about some simple image processing techniques called erosion and dilation. So last time we found all the red pixels in this image, and we found a couple of errors here. There's these spots here that shouldn't be there that came up with the red filter, and then a couple spots in the ribbon here that just weren't quite filled in that probably should have been. So how do we fix this? How do we get rid of the spots and fill in the gaps? Well, we use morphological operations. And that's a long phrase. Really means what we're going to do is have a couple of methods here that grow or dilate and shrink or erode regions inside of an image. And so this can be used to remove some of that noise that we saw there. It can be used to increase the size of objects, which can be useful if you want to account for some errors. So if you see something ahead of you, you really want to make sure you don't hit it. Maybe you dilate a little bit to make it look a little bit bigger, and then you'll have a little bit air margin to go around it. And then it can be used to fill in gaps in what should be solid objects. So really what we're trying to do is get rid of these dots and fill in these spots. So let's start with erosion. Erosion shrinks regions in an image. The process here is pretty simple. You scan all the pixels in the image one at a time. For each of those pixels, you look at all their neighbors. So usually we do this in a 3x3 grid. You may sometimes want to do like a 5x5 grid, which would be neighbors 2 spaces away. But for the purpose of this example, we're going to stick with a 3x3 grid, and you find the minimum value of the pixel and its neighbors. And then you set that pixel to that new minimum value. So how does this work? Let's bring back our low-res image of Abraham Lincoln that we used a few videos ago. And let's look at a region over here. So this is going to be this spot right here on the left of Lincoln's head. We've got this sort of white pixel, the gray pixel, and then the darker pixel here. And we're going to say that our erosion process has gotten to this pixel in the center here. So the pixel with the current value of 109. And we're going to look at all the neighbors here and see that there's a 5. 5 is the minimum value of all the neighbors. So this new pixel in the center is going to now be 5. And what's that going to do to this image? Well, if you think about it, we're talking about this pixel here. It's going to become the blackest of all the neighbors around it. So it's going to be this spot here moves over to the center and grows in size a little bit. Now, this is a little bit confusing because every time the white regions shrink, it means the black regions grow and vice versa. So really what we're saying is that this lighter gray area here shrinks because it becomes darker gray. And of course that means the darker gray area grows correspondingly. So how do we do this in OpenCV? Well, in OpenCV we use what's called a kernel, which we're going to talk a lot more about in the next couple of videos. We create a kernel and we tell it to do 3x3 because we were talking about a 3x3 grid here. If you wanted to do 5x5, you'd put 5x5 in here and so on. And then we just tell OpenCV to use the erode function on your image using that kernel. Alright, now dilation is basically the opposite of that. We grow regions in an image instead of shrinking them. It's a very similar process. We scan each of the pixels one at a time, but this time when we're looking at the neighbors of the pixel, we want to find the maximum value. This is because we want to grow the white pixels in the image, the lighter pixels in the image, and make them bigger regions. So we take that maximum value and set it as the new value for the pixel in question. Again, going to this region on Abraham Lincoln's hair, and we again look at the 109 here. We look around at all the maximum values and we see this 206. And so we say that this 109 is now going to become 206. And this is going to have the effect of growing this lighter gray region here into this area here. It's a little bit darker gray, which is going to have the effect of shrinking his hair and growing the white space around it. Because again, we talk about these terms in terms of white growing and the darker gray areas shrinking. In an OpenCV, this looks very similar to the erosion function. You set up your kernel, you again give it the size of the grid you want, and then you use the dilate function on your image using that kernel. So let's try this to actually remove the noise in the image that we were talking about at the beginning of this lecture. So first off, we're just going to do an erode 3x3. And that works pretty well. There's no more errors in the center here. But we've managed to grow the gaps here, and that should be expected because all of those white regions are going to shrink a little bit, so any gap you had is just going to get worse. So what can we do to fix this? Well, we can use our dilate and basically just undo what we did before with the 3x3 kernel, and that doesn't bring back any of the center pixels here that had problems, but there's still some gaps along the ribbon itself, and so maybe we want to use a bigger dilate to get rid of the original errors as well. So let's think about maybe a 7x7 instead. And this works pretty well. You may want to go with 9 by 9. They're usually odd numbers, so you haven't defined center, but you may want to go with a 9 by 9, but that's also going to make the ribbon wider and wider. So if the width of the object you're finding is important to you, then you would want to calculate the exact amount of erosion to do after this to undo this. So then if we eroded 3 by 3 and then dilated 7 by 7, we'd still have 2 more pixels wider than we were before, so we'd want to take those 2 pixels away with, say, an erosion 5 by 5 to make up for it. But for this purpose, it works pretty well, and we're just going to leave it at that for this one. So to review, erosion reduces the size of the regions, dilation grows the size of the regions, and use them together to remove the small erroneous regions and fill the gaps. And you sort of alternate which one you use to undo the effects of the previous one while still accomplishing what you're going for. And you may or may not want to use this in your lane filter when it comes to it. I presented this to you so you could be aware of it and use it if you need it. If your lane filter is pretty good, then you might not need to fill in any gaps or get rid of any spurious pixels, but you may want to use it at some point.